Hey guys, in this video I want to go ahead and talk to you about multiplying and dividing complex numbers. So we've learned how to change a complex number into its trig form. Okay, so now what we're going to do is we're going to be multiplying. I'm just going to go through it real quick how do we get to this thing about multiplying complex numbers. So your complex number is represented by the z, a plus bi. And so this is the trig form of the complex number. Okay, so we're going to be multiplying these two. So essentially what we have is this. You're multiplying here. You have R1 times R2. These are the modulus, okay, or the moduli. And so you're multiplying this guy times this other guy. And essentially what you're doing is you're doing the distributive property. So this cosine theta of the first angle times this cosine theta. This guy times this guy gives me this. This guy times this guy gives me this. And then I times I is I squared, and sine theta 1 of sine theta 2. So that's what's happening. Well, let's go ahead and simplify that some more. So then this stays the same. And then so here I'm going to have, okay, I'm going to have two of these. Okay, we're going to add these. But what I did is I squared is equal to negative 1. So we're going to have negative 1 from here, sine theta 1 of times sine theta 2. So I put it over here. So these go together, okay? But what I did, I just factored out the I, and then you have cosine theta 1 times sine theta 2 plus, and cosine theta 2 and sine theta 1. So I combine these two here, okay? The I squared became the negative, and then this guy you bring it down, and this guy goes over here. So we're combining the real parts and the imaginary parts. Well, if you remember, this actually is your summation and your difference formula. And so this becomes cosine of a plus b, and this guy becomes sine of a plus b. Or actually this is cosine of a plus b because of the minus, all right? And so that's how we get this from the summation formulas. So this is basically your formula, your pattern to multiply the products, multiply the complex numbers, and then to divide the complex numbers. Essentially what you're doing is you're multiplying. When you're multiplying the complex numbers, you're going to multiply the modulus or the moduli, okay? And then you're going to add the angles, okay? And then for the division, you're going to divide each modulus, and then you're going to subtract the given angles that correspond. So the cosine angles, you're going to subtract them. The sine angles, you're going to subtract them, and then you're going to do the math like we did in the other videos. So let's go ahead and do one example here real quick. So we have this guy given this complex number and then this other complex number, and it tells me find the product. So what I'm going to do is 3 times 4. Okay, so first I wrote it out, okay, but then 3 times 4 is 12. And then the cosine angle of this guy is going to go with the cosine angle of this guy. So I'm going to add it. So 2 pi over 3 plus 5 pi over 6. And then the same thing with the sine. 2 pi over 3 plus 5 pi over 6. So they go together. And so then all I have to do is add this. Well, I need the same denominator. So 2 pi over 3 is the same thing as 4 pi over 6. So if I do 4 pi over 6, then this becomes plus 5 pi becomes 9 pi over 6. Same thing over here. So now I've reduced 9 pi over 6 is the same thing as 3 pi over 2. And cosine of 3 pi over 2, if you remember on the unit circle, okay, 3 pi over 2 is down here, and that's the angle 0, comma negative 1. The cosine would be 0, and then the sine would be negative 1. So then I just simplify it out. I end up with negative 12i. And that's what we're doing. Okay, that's all we're doing, guys. So let's go ahead and see if we can do a few more. Maybe 3 more. Okay, so here we have a different example with degrees. Same thing, but now what are we doing? We are dividing. So we're going to divide the modulus, okay, the R value, the absolute value distance. So it's going to be, you're going to have 32 divided by 4. Now be careful, because remember, division is not commutative, so the order does matter. but I don't think this is going to give you anything too complex. They always tell you z1 over z2. So just make sure this guy's on the top. So we're going to have cosine of 315 minus the cosine of 90. So I'm going to go ahead. I know I have to use cosine, and I should have used brackets, but it's okay. Cosine. So I'm going to use 315 minus 90 degrees. Okay. And then plus I sine. And notice that in the middle it's plus, but I'm actually subtracting the angles. So 315 again minus 90 degrees. Okay. And then 32 divided by 4 is 8. And then 315 minus 90 is 225 degrees. Plus I sine of another 225 degrees. Okay, I really don't like working with degrees. It's a lot easier for me with radians, but it's up to you guys. But 225 degrees, what is that? That's the same thing as 5 pi over 4. Okay, so 225 degrees is the same thing as 5 pi over 4. Okay, and I like using that because I can use my hand mnemonic. Okay, so what does that become? Well, 45 degrees is right here. I need the cosine, that's 2 fingers on the top, so square root of 2 over 2. So this guy is square root of 2 over 2. The problem is it positive or is it negative? Well, pi over 4 is over here. 5 pi over 4 is in the third quadrant. Over here, all sin tacos. Only the tangent is positive. Well, that's not tangent. So this guy's going to be negative. And then we have I. And then do the same thing. 225 degrees, same thing, is the same thing as 5 pi over 4. You bend it. On the bottom is the sine, so that's root 2 over 2. And again, it's negative because if it's in the third quadrant. All right, so we have that. And all I have to do now is distribute the 8. So let's see here. 8 divided by 2. I guess I can just go ahead and do it the long way. Like this, bring out that negative, and then minus 8, I 8 radical 2 over 2, and that becomes negative 4 radical 2 minus I of 4 radical 2. And there it is, guys. So that I found the product. Okay, let's go ahead and do another one. I'm sorry, I found the quotient for that one. Let's go ahead and find the product here for the next one, number 3. And remember, so we are multiplying the modulus, the moduli. We're going to be adding, okay, the angles, okay? So we're going to have z1 times z2. We're going to have 1/2 times 8. And then we're going to have cosine. And what are we doing with the angles? We're adding 30 plus 45. 30 degrees plus 45 degrees. Okay? And then continue plus I. Same thing, sine of 30 degrees plus 45 degrees. Okay, we do that. Half of 8, that is easy. That's going to give me 4. So now we have cosine of 75 degrees. And then the question is, well, I don't know cosine of 75 degrees. That's right. So what do? You're just going to have to use a calculator. And no big deal. So let's go ahead and do that. So you have to find cosine of 75 degrees. Now, remember that you can either have degrees or radians. Okay. Now, the reason I know this is degrees is because it has a little circle. If it has like a decimal, like let's say 4.3, 2.2, and there's no degree, then I automatically know it's a radian. So just keep that in mind. So cosine of 75 degrees is 0.921 217 plus I, and then I have to do the sine of 75, and that is negative 0.3877, and all I have to do now is just distribute that 4. So it's going to give me, this is negative 1.551 I, and then 0.9217, multiply that times the 4, is 3.6868. Okay, and there it is. You found the product of these two complex numbers. Okay, guys, let's go ahead and do one more. So it looked kind of difficult, but not really. So now we're dividing again. Okay, so again, remember, we're going to subtract. So we're going to subtract the angles. Now remember, we're going to divide these guys. The modulus, 3 divided by 1/2. Okay, so we're going to end up with 3 divided by 1/2, which is the same thing as 3 times 2. So that we're going to have cosine of 2 pi over 3 minus 5 pi over 12. So 2 pi over 3 minus 5 pi over 12. Okay, plus I sine, and then same thing, 2 pi over 3 minus 5 pi over 12. All right. So then we're going to go ahead and we can do this math here. Remember, dividing is the same thing as multiplying by the reciprocal. Well, the reciprocal of 1/2 is 2. So 3 times 2 is 6. Now what about this guy? 2 pi over 3, and this is 5 pi over 12. We need the same denominator. So this is 2 pi over 3 becomes 8, right? If I multiply everything by 4. So this becomes 8 pi over 12. 8 pi over 12 minus 5 pi over 12 becomes 3 pi over 12. Okay. Plus I sine, same thing over here, becomes 3 pi over 12. Okay. So 3 pi over 12, if I reduce it, that becomes pi over 4. Okay. Plus I sine of pi over 4. All right. And then I can go ahead and finish it. Well, cosine of pi over 4, boom, here, root 2 over 2. Top fingers are cosine. So that becomes positive root 2 over 2. Is it positive or is it negative? Remember, pi over 4 is in the first quadrant. So right here, all of the trig ratios are positive, which is great. So we go over here to this sine. Sine of pi over 4, same thing. Bend it. The bottom is root 2 over 2. And if you notice, I messed up. I shouldn't have put this guy here. Sorry. So this is root 2 over 2. And all I have to do is distribute that 6 now. So then I should get 6 radical 2 over 2 plus I 6 radical 2 over 2. And when I clean that up, I should get 3 radical 2 plus I of 3 radical 2. And that's it. All right, guys, so not too bad, not too difficult. Hopefully that helps. I'll see you guys next time.